So let's start with exercise 1F. I'm reading the question for you. First question is, find the measurements below in the form a into 10 raised to n, where you have to write the number between 1 and 10 and n is an integer. So our first sum is density of air at 27 degrees Celsius and 1 atmosphere pressure is 0.00161 gram per centimeter cube. Now this number you have to write it in standard form. So basically this decimal which is there, you will shift this decimal in such a way that this 161 we write the number in such a way that it is between 1 and 10. So the point shifts from here 1, 2 and 3. It's gone 3 places. So basically the point is here and we write the number 1.61 into 10 raised to, you have shifted this 3 places and your number the zeros are before your number, so you will add a minus here and write minus 3, 10 raised to minus 3 gram per centimeter cube. The same thing we will do with the B sum, which says the radius of a calcium atom is 0. There are various zeros given, 197 meters. Now here basically my decimal will come between 1 and 97. If you put your decimal after 19, that means this number becomes 19.7, which is greater than 10. So always you need to take care of this, that your number is between 1 and 10. So basically I have to bring my decimal here. So again 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So my answer would be 1.97 into 10 raised to minus 10 meters. The C1 is 1 light year is 946 and several zeros given kilometers. So this sum now here, I have to put a decimal here between 9 and 46. So 9.46 and from here count the number of places. You have brought the decimal from here to 9.4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So here into 10 raised to 12 kilometers. Okay, now the difference, you see the difference between first, second and third. Here the zeros are after the number. So this will come positive 12. Okay, and if the zeros are before the number, then you put a minus sign. So minus sign if the zeros are before the number, and a positive 1, like if it is positive you don't put a sign if the zeros are after the number. The next one is quite a big number, where it says the mass of neutron is given several zeros and 1675 grams. So here very quickly let me count the number of zeros. It's 3, 6, 9, 12, 15, 18, 21, 22, 23 and 24. Your decimal will come here. So 1.675 into 10 raised to minus 24 grams will be your answer. So this is the way we write standard form of a number. Okay. So these are the basic 4 sums which are given in question number 1. Now let's move on to the next question, question 3. Now in question 3, here I'll read out the question. The image of a speck of dust viewed through an electron microscope is 1.2 into 10 raised to 2 millimeters wide. The image is 5 into 10 raised to 2 millimeters as the actual size. Determine the width in millimeters of the actual speck of dust. So here, to find the real size, what we have to do is size in microscope over, you will divide it with the magnified image. So will be 1.2 into 10 raised to 2 over 5 into 10 raised to 2 millimeters. Now 10 raised to 2 in the numerator denominator you can straight away cancel. 1.2 over 5 gives me 0.24 millimeter. Now 0.24 in standard form I can also write it as, shift the decimal here. So this becomes 2.4 into 10 raised to minus 1 millimeter. The B sum is convert the following from scientific to decimal notation. So 5 into 10 raised to 3. Now this is quite simple. You have to just convert it into a decimal notation. So 10 raised to 3 is 3 zeros. So 5000 will be the answer. Okay. Now let's move on to the fifth sum here. It says, I'll read out the sum for you. 1 millimeter has 15 drops. 1 drop of water has 1.67 into 10 raised to 21 H2O water molecules. Estimate the number of molecules in 1 liter of water. So here basically 1 milliliter has 15 drops. So 1 drop has these many molecules. Therefore 15 drops will have 15 times 1.67 into 10 raised to 21 molecules. Now if you put this in your GDC you will get the answer as I've already done it, 2.505 into 10 raised to 22 molecules. Okay. Now here the question is, this is 15 drops. The question is estimate the number of molecules in 1 liter of water. So basically 1 liter is 1000 ml. Okay. So in 1 liter you will find 2.505 into 10 raised to 22 into 1000. Now 1000 I can also write it as 10 raised to 3. So when you calculate this, your answer will be 2.505 into 22 plus 3. That is 25 molecules. This is the final answer. Now we move on to the sixth sum here. Scientists announced the discovery of a potential planet 9 in our solar system in 2016. The so-called planet 9 is about 5,000 times the mass of Pluto. Pluto's mass is 0.01303 into 24 kgs. So the question here they are asking, A part is planet 9, calculate the mass of planet 9, write down your answer in standard form. Now basically to find out the mass of planet 9, what I will do is I will multiply 5000 with Pluto's mass, that is 0.01303 into 10 raised to 24, which when you multiply in your GDC it will give you 6.515 into 10 raised to 25 kgs. Okay. The next one, B part of the question says the Earth's mass is 5.97 into 10 raised to 24 kgs. Find out how many times planet 9 is bigger or smaller compared to the Earth. Write down your answer correct to the nearest digit. Now to find out the mass of planet 9, how many times it is larger, what we do is this answer which you have got here, planet 9's mass 6.515 into 10 raised to 25, you divide it with the mass of the Earth, which is 5.97 into 10 raised to 24 kgs. When you solve this, you will get the answer as 11. So you can say planet 9 is 11 times larger. Okay. There are more sums. Now I would like you to just try on your own the way we have solved these sums and just see if you can solve. So this was all about exercise 1F. In the next video, we will try to solve sums from exercise 1G. Okay, goodbye.